Hi, welcome to part 2 of this lecture for designing classes. Another terminology that we haven't talked about is responsibility-driven design. What does that mean is that each class should be actually responsible for handling its own data. Sometimes we might need to add some new functionality to our program, so we need to basically kind of look at to see which classes we should add a method to implement this new functionality. So which class should be basically responsible for this task. And so when we look at that, we kind of understand that the class that is responsible for storing some data should be also responsible for manipulating that data. How well responsibility-driven design is used, it can actually influence the degree of our coupling, which we have talked about it in previous lecture. And so basically, that is very important that we need to pay attention to that. So just something to remember. Remember, just coupling refers to link between separate units of program. If two classes depend closely on many details of each other, we say that they are tightly coupled. Remember, our focus is to have low coupling. The idea is to do loose coupling. A class diagram can actually, we said that it can provide the hint for us on how exactly our classes are linked to each other. So we are aiming for actually loose coupling. But remember, we are aiming for high cohesion. So loose coupling make it possible for us to understand one class without being able to read the other classes to understand that. And as we said, changing one class with little or no effect on the other classes. So you don't have to change your many classes in a program if you change just one class. So the loose coupling, it increases also the manageability. As we said, we try to avoid tight coupling. And changes to one class bring a cascade of changes to other classes we just talked about. And classes are harder to understand in isolation. Flow of control between objects of different classes is basically very complex. So remember, we want to avoid having a tight coupling. On the other hand, as we talked about, cohesion refers to number of diversity of tasks that a single unit is kind of responsible for. And we said each unit or each program is basically responsible for one single logical task. So we say it has high cohesion, and we aim for that high cohesion that we have. And we said unit apply to classes, methods, and modules. So that program unit can apply to classes, method, and modules. So again, remember, we aim for loose coupling, but we aim for high cohesion. So some of the reason that we aim for high cohesion is that basically high cohesion makes it easier for us to understand what a class or method does. So, and also we use descriptive name for variable, method, and classes. And another popular advantage is that if you use high cohesion, you can actually reuse your class in another context. So reusing class and method in another context is another reason why we want to aim for high cohesion. On the other hand, loose cohesion, we are trying to avoid that, because in that way, your method could perform multiple tasks if you put it in there, and then it's hard for us to understand that method, and we cannot reuse it. So, and each class doesn't have an identity if it does a lot of different things, so you are not sure what's the purpose of that class. So we are trying to avoid loose cohesion. So cohesion can apply at different level. It could apply both at the class level and at the method level. So when we are talking about high cohesion for the classes should represent one single well-defined entity. So that class can do that one thing that we are aiming for it. And if you are applying it to the method level, a method should be responsible for that one and only one defined task. So again, you want to focus on that, having a method that just does one thing. So the aim of it is that we can reuse this method in another context of our program, or we can reuse our class in another method of that, in another part of our program. So another concept that we are going to talk about is code duplication. As we saw in the Zool project, duplicating the code is a bad design, and it's basically making it for the programmers to maintain it, and it can actually lead to errors during the maintenance. So you want to avoid as much as possible as code duplication. One of the concepts in Java is inheritance that we will learn in other chapters in a couple of weeks, that you can use that in order to avoid the code duplication. So we talked about the responsibility-driven design, and we said why that is important. So some of the questions that you might want to ask, basically from yourself, where should we add a new method? In which class we want to do that? So basically, which class should be responsible for that task? And we said that each class should be responsible for manipulating its own data. So because that class is responsible for storing the data, it should also be responsible for manipulating the data. So the class that owns the data should be responsible for it. RDD can lead to low coupling, and so that's another thing that you want to remember. So we are trying to localize the change. So one of the reasons for reducing coupling or loose coupling and RDD design is basically to localize that change. So when a change is needed, as few classes as possible is going to be affected. So you're not required to change a lot of classes because of that change, which just could lead to a lot of rework and also errors and things like that. So we are trying to actually localize the change. Another thing that we need to focus on when we are designing a class, we need to think ahead. We have to think about how the changes could affect the program in the future. And again, we are trying to aim to make those changes easy. So that's why we are going to kind of look at the loose coupling. We are looking at the RDD design and all of that, so that we can actually make those changes. Also, another thing that's very important, that's why I asked you guys to kind of draw the class diagram, because then in that way you can see especially for loose coupling, if the classes are dependent to each other, and you will see that in the class diagram. Refactoring is another concept that we need to focus on. When classes are maintained, often code is being added. Classes and methods, they tend to become longer, so you might keep rewriting all these code that might not be necessary. Every now and then, the classes and methods should be refactored to maintain cohesion and low coupling as well. So as we saw in the Zool project, we actually create a method print location info method that will have all those code underneath it, and then we would just use, for some part of the duplicate code, we would just put the word print location info method, and it will bring all those code and applies it. So we use this method to be able to actually avoid the redundant code. So that's why classes and methods sometimes they try to become longer in that way. And as we said, we are always trying to add and upgrade basically our classes and our methods, and in order for us, we have to refactor in order for us to have high cohesion and low coupling. So as we said, we are doing this because we want to make sure that this unit is responsible for that, this method is responsible for this, and you don't want to have classes that are dependent to each other. It's true, the classes has to communicate and cooperate with each other, but they shouldn't be dependent on each other. Also, when we are refactoring our code, we need to make sure that we are testing it. So first do the refactoring only without changing the functionality, and then test it to see if that refactoring worked. And then you can basically making sure that your program is not broken or anything else is not broken. So you can test before it and after refactoring to making sure that that program, the functionality is doing the same thing, even though you changed the program, you brought some method in there to avoid the duplication of the code, but your the program still does what it's supposed to do. Just some design guideline. Basically, just don't put too much into a single method, or don't put everything into one class. So some questions that you should kind of consider: how long should a class be, and how long a method should be. So that's very important to think about. Remember, if a method is too long, if it does more than one logical task, then it's not good. And a class is too complex if it represents more than one logical entity. Again, we want to think about this question in respect of high cohesion and loose coupling. So that's important that we need to think about it. Some other designing guidelines, as we said, a method is too long if it does more than one logical task, and a class is too complex if it represents more than one logical entity. So these are just guidelines. They still leave a lot to the designer how to design a program, but again, remember, you want to design a class or a method that can be reused somewhere else in another context. And also remember, right now in the Java library, you are using some other people's classes that has been written. So if that class is doing more than what it's supposed to do, then you're not going to use it in your program. The last thing that we are going to talk about in this chapter is enumerated types. Basically, this is just a syntax or feature of a Java. It uses enum instead of class to introduce a type name. Their simplest use is to define a set of significant name. A static integer constant is a way to use it when the constant value would be arbitrary. So this is the basic enumerated type basically that we are using in here. Each name represents an object of enum type. The command word.help that you have in the project. Enum objects are not created directly, and the definition can also have field, constructor, and method, as you can see this in the project that we just talked about. So just for a review of this chapter, remember, programs are basically continuously changing. So it is important for us to keep up with this change. The quality of code requires much more than just performing correct at one time. We need to pay attention to the quality of code by having the concept of cohesion, and also the RDD concept, and basically thinking about the refactoring, and as well as coupling. So code must be understand and maintainable. So we said we want to avoid duplication. We want to make sure that we have high cohesion and loose coupling. And in the coding style, we want to always try to have some documentation for commenting, for our naming, for our layout. We also want to think ahead into our design. So there is a big difference in the amount of work required to change poorly structured and well-structured code. So you want to make sure that your code is well structured. And remember, you can just use a method to avoid the rewriting the code, and just bring that method into your program. And other thing that you want to remember, that your classes should not be dependent to each other. So if you change one class, you don't have to change all of these other classes. And that's very important to think about as well. And the concept of inheritance, we will talk about it later on in the other chapters, that how some classes can be a subclasses of the super class and things like that. And so in that way, you are not going to actually write all these programs, all these codes, so you can simplify your code as well. I hope you have enjoyed this week's lecture, and please, if you have any question, please let me know, and I will look forward to hearing from you with any comments, questions that you have. And remember, next week we have a midterm, and the midterm, as I mentioned before, will be multiple choice and some essay questions. It's not going to be too much focus on coding, and but for your final, you have to write some codes, and that's important. And remember, your assignment has a big chunk of grade on it, so you want to make sure that you submit your assignments on time and actually get help from the tutor if you need to. I hope you have enjoyed this lecture, and have a good day. Bye bye.